From the first part, you already know that you should not catch every exception with a blanket catch statement, and you also learned how to get error messages over to your state management solution, such as a ChangeNotifier. And some may say, that's it. But as proper software developers, we should prefer hard rules over simple conventions. And currently, we won't get any compile time or even runtime errors when we do not display an error message to the user. And in fact, we have to remember to display it, as you can see in main.dart. If we leave out this if statement, which checks for if failure is not null, really nothing is going to happen and our app will compile just fine. And secondly, we treat error flow and success data flow separately. That is through exceptions, as we can see in post ChangeNotifier. So whenever an exception happens in the call to post service, we catch it and set a separate failure field. If there is no exception, we just continue along with the code execution and set a separate post field in the ChangeNotifier. So we have separate field for post and also for failure. So is there a way to join the regular success data flow and error flow, and also to join these two fields into just one and overall create a more robust application? Well, of course there is, and you are going to learn how to do that in this tutorial. Hello, welcome to Reso Coder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming sought after developers. And also be sure to check out fluttereurope.dev if you want to meet up with the Flutter community, including me and people from Google and Felix Angelov, who made the blog library, and overall many awesome people will be there in Warsaw, Poland this January 2020. There are just really a few tickets left and it's going to be an amazing conference, so go to fluttereurope.dev or also to the link in the video description to learn more. Although the code we currently have works just fine, as I said, we want to make it more robust. And if you have forgotten how it works from the previous part, we can get a post and it can display either the post or some sort of an error message. And we are faking exceptions by simply throwing them directly from a fake HTTP client. And definitely, if you have not seen the previous part, check it out from the card in the corner. We're going to make this code more robust by introducing a bit of functional programming, which is known for its terseness and reliability. And also, we're going to introduce algebraic data types. That's nothing else than just a different name for things like sealed classes from Kotlin or tagged unions, or some powerful enums which are available in the Swift programming language. And these algebraic data types, such as either, can be used to reduce error-prone boilerplate to a minimum. And before continuing, just be sure to check out the written tutorial from the link in the description, where you can find all of the code written in this video. You can also find the links to the libraries and overall go through all of these explanations at your own pace. Dart is a language which does not support functional programming paradigms out of the box. It does support some, like you can pass functions around as first-class objects, you can have higher order functions, but it probably ends there. What's missing in Dart natively is a great functional programming library. Languages like Scala, Haskell, F#, and even Kotlin support certain functional programming paradigms out of the box. Of course, Haskell and Scala, but mostly Haskell is just purely functional language, so that's awesome, but Dart is not designed to be that way. However, there is an amazing package called Darts, and it introduces types like either and task, and many more functional programming concepts which we are not gonna get into in this particular tutorial, but definitely stay tuned for more tutorials about functional programming, so subscribe and hit the bell if you don't want to miss them. But we're just going to focus on a small subset of the Darts library, which will make error handling a breeze. So before continuing, let's add Darts into our project. It's currently under development, so we're going to use the version 0.9.0 dev 5, and make sure to use this same version in your own projects if you want to follow along with this tutorial. Even though we're using development versions, the API for the things which we are going to use should really not change at all in the future. Let's go over what needs to change and what does not need to change, because of course, some of the things which we have written in the previous part are just perfect for using darts too, with the either type and with the task type. For example, what does not need to change is how we throw exceptions from the fake HTTP client in the post-service.dart file. That's perfectly good. And also what does not need to change is that we catch only certain types of exceptions in the post service and convert them to failures. This is perfectly fine to do also when you are using the package darts. So the failure class remains unchanged, and overall, basically all of the content of the post-service.dart file can remain unchanged. What we need to change is the post ChangeNotifier, because as you remember from the beginning of this video, we want to unify the post type and the failure type. Also, what needs to change is the way that we catch the failure. And finally, of course, we want to change this if statement to something more reliable, which, when we forget to check for a failure, will not allow us to do that, because currently we can just remove this if statement and return only the success data, the post converted to string, without even checking for failure, and we get a free pass from the compiler. It does not complain. However, we want to have compile time errors when we do something like that, like not checking for a failure, right? Because that's definitely not a good practice to let failure just pass through. So let's start off in the post ChangeNotifier, and let's talk about these two fields. We of course need to have the state field. We are not going to do anything with that, but these two fields, post and failure, should really be just one field. Because logically, we cannot display a post when a failure has occurred. When there is a failure, the post will be basically null, or the post will contain some old data before a failure happened, and either way, we should never display a post when we have some sort of an error. What I've just described is also called improperly modeled domain. And again, it stems from relying on best practices like having to remember to check for a failure, and not on hard rules like you cannot ignore to check for a failure because otherwise the code won't compile. Proper domain modeling can be achieved with the either type, which will hold both a failure and a post. So let's introduce the either type over to our code. Of course, our code will break because we are not expecting the either to be present in here in other layers, for example, in the UI, but we are going to fix that later. So for now, instead of having just a single post held inside this post field, in this triplet of post related fields and getters and setters, we're going to hold an either type, which comes from darts, so let's import that, which will hold either a failure or a post. And now, of course, we want to change all of the occurrences of post to say either failure or post. And with this done, we can now completely remove the separate failure field because it's no longer needed. Before jumping into how we can actually get either a failure or a post over to this field from this getOnePost method, we are first going to take a look at how we can use this nice post getter from within the UI. So let's jump over to main.dart, and we're going to refactor this ugly if statement into something where it's almost impossible to not handle the failure case. In fact, it's much harder to not handle a failure in the approach which we are about to take than to handle it properly. Replacing this if statement is possible by using a fold function. So we're going to return notifier.post, which is now holding the either type. And now we want to fold this either. And fold is a higher order function which accepts two functions itself. The first one is if left, which will grant us a failure, And over there, we just simply want to return a styled text. So we can just copy it from the old if statement, which will get us a failure converted to string, just like that. And if we are on the right side of either, so basically if the either contains not failure but the success data, which in this case is a post, we will want to output a styled text which holds the post converted to a string. And if we add some commas in there so that it's nicely formatted, all right, that looks about correct. We can now remove this if statement. And basically we have just fully refactored the code to use fold. And with that, we have introduced an amazing feature, which is that we now prefer hard rules over soft conventions. Because if we now decide to not handle failure, if we delete this, well, we get an error here saying that 2 positional arguments expected, but 1 found. So that's awesome. And if we now handle failure, what are we going to output from here if not some sort of a styled text, right? We can ignore it. We can just return container, or actually without the return statement because we are in a single expression method. But doing this is not something which you would probably do, right? If you are here, you may as well return a styled text. Like, it's not that hard. So this way, it's much easier to follow the rules than to break them, because you are going to be notified when you break them, and you won't even be able to compile the code unless you handle a failure. With this done, we know how to use the either type from the UI, but how do we actually get either the failure or the post into this type, into this post field? If you've seen my clean architecture and test-driven development course, and if you haven't, definitely check it out from the card in the corner. Over there, we populated the either type pretty naively, but in this tutorial, we are going to utilize functional programming to the fullest. For that, we need to introduce another type in addition to either, and that type's name is task. As you surely know, Dart has a concept of a future, and doubtless it's a huge help for any Dart developer. However, futures aren't necessarily without side effects, and without getting too deep into some functional programming concepts, let's just say that futures which are native to Dart are not exactly functional programming friendly. So that's why the Darts package has a wrapper for a future, and it's called task. And with it, you can use functional programming to really cleanly set up a sequence of functions which are going to be executed whenever that future completes and runs. So again, this is a bit abstract, so let's go bit by bit and break it down into small chunks. We're going to modify the code which is present inside getOnePost. So let's actually completely delete this try catch block, and we're going to implement it using task. We are at first going to write task, which comes from the Darts library, and this takes in a function which should return a future. So we are going to provide such a function to the task constructor. So we're going to have a function returning the future from calling post service dot get one post. All right, so we are simply wrapping the future inside a task. Now what we can do, which is pretty cool, is to attempt to run the task. If we take a look at the return type of attempt, it basically waits until the future is completed, and then it puts success data into the right side of either, or if there is some sort of an error, it puts that error casted to an object to the left side of either. And let's actually take a look at attempt's implementation by hitting F12 in VS Code. So its implementation is fairly straightforward because functional programming is all about immutability, which means that you do not modify data structures or classes or fields, but you rather create new instances of them. Something like when you modify a string, it's very similar to that. it creates a new instance of a task, and inside of it, it runs the future, and then if it's successful, it puts the successful data to the right side of either. Otherwise, it catches an error, and then it puts that error casted to an object to the left side of either. And you may have noticed that this attempt function is doing something which I was really against in the previous part, and that is catching all errors, all exceptions, and not just certain types of exceptions. We're going to fix this later on in this tutorial. So let's just now focus on continuing with implementing the code. So after calling attempt, we have an instance of task which holds either an object or a post. So what we want to do now with this is to convert the task back into a future. So we're going to call run, because of course we need to work with futures as those are native to Dart. So basically there is nothing hard here. It just converts the task to a future, and this future still holds an either object post type. And now we could even await this future in a regular way by writing await, but we are going to use a then continuation on this future. This is really just the regular then, which you use with regular Dart's futures. Nothing scary in here. So this grants us a value, and in this function we are going to simply set post and pass in the value. So setPost is just our regular setter, which accepts an either holding a failure or a post. And whenever it's called, it just as usual notifies listeners so that the UI rebuilds and we can output a nice text to the screen. But the code written like this would not exactly work. We are missing one key thing, and that is await. And we want to await the whole call chain here. What this means is that we are awaiting the very last function call in this chain, that is the then call. So whenever the set post is actually called, this future, this bottommost future will complete. And we need to await this bottommost set post future because we want to set state to be loaded afterwards, so that we stop displaying the loading indicator and instead we can display the actual data. Because whenever the state is loading, we never display data, we display only the circular progress indicator. And with this done, when we now save the code, it should actually work, right? Inside the post service, we are currently throwing an HTTP exception. So we should have an error message saying couldn't find the post, right? So let's open up the emulator and see if it works. Get post. And we have an exception occurred. That's fine because VS Code decides to stop even at these kinds of exceptions, which are actually handled. So let's just continue. But this is sort of unexpected because we have a type error saying that type left object post is not a subtype of type either failure post. Interesting. So let's just continue. And the app will just not work. It will just continue spinning this circular progress indicator. So something is not correct in here. Let's just try this when we don't throw any exception, but we just return the success data. So once we save that, we continue on with getting the post. And now we have another type error, but this time it's not that the left is not a subtype, but right is not a subtype of either failure post. You may think like, what is going on with these left types and right types? Like, aren't we just using either here? Well, yes, but either is basically what you would call a sealed class in Kotlin. So it has two subclasses. If I scroll down here, oh my, there's a lot of code. So here we go. We have left and right, which are both subclasses of either. So there is definitely not a problem with these subclasses themselves. Let's just see the error message one more time to see that the issue is in this dynamic. Dynamic cannot be cast into failure sort of automatically. And similarly, when there is an error thrown from the post service. So we uncomment, for example, HTTP exception, and now we run the code. The issue now lies in this object. Object cannot be simply cast into a failure with an implicit cast. This cast needs to be explicit, not implicit. All right, so let's move on and let's fix this casting issue. You all know how to cast a simple object. So for example, when I have var obj is equal to object and simply instantiate a plain object, and we want to cast it to failure, we can do final failure, or f is equal to obj as failure. This is a simple cast. And of course, currently it would not work, but if we were to store a failure instance inside an object, so we would do something like this, and a message here. Now this cast would function because object really holds a downcasted failure, so we can cast it back to failure very easily without any errors. So this is how regular casting works, and we are going to do precisely this kind of a casting, but inside functional programming paradigm. That's because when you look at the output type of attempt, we can see that it holds a task, which holds either and only that holds this object, which we want to cast to a failure. So we need to get 2 layers deep into a task and then into either, and only then we can cast this object to a failure. So how can we do that? Well, we can map over this return type of the attempt function very much like we can map over a list. When you have a list here, 1, 2, 3, you can use map, which grants you a function passing you an integer I. And from here you can simply return, for example, even a completely different type, so maybe convert it to string, right? So you're going to interpolate I, convert it to string, and this map function now returns an iterable of type string, so we can do something like for each string s output, so print its s.length. So this is what you can do with regular iterables. You can map over them, and it's going to map every single element to some other type, possibly. It doesn't have to, but you can even map to other types, as we are doing over here. And then the return type of this map function is an iterable of that other type. In this case, we converted iterable of integers to an iterable of strings. So when I now delete this, we're going to do a very similar thing to the task, and we are going to map every single output of attempt, which currently holds a task of either object post, to a task either failure post. So let's do just that. Map, which grants us either object post, so that inner type which is held inside the task. So we want to grab this either for sure, but in addition to that, we want to map even the stuff which is inside either. Why? Well, because this either is what holds object post, but we want it to hold a failure or a post, not an object. In other words, we want to map the left side of either to something different. So instead of simply mapping it, we're going to say either dot left map. And left map does just what it says. It maps the left side, L2, to possibly some different object with a different type. So let's just say that this function will grant us an obj object, because that's precisely correct, since the left side of our either currently holds an object. And we want to cast it as usual to a failure. So we are going to return obj dot or as failure. And when I add some comma so that it's nicely formatted, we are practically done. I say practically because there is still some more work we can do to perfect this code, but this is good enough because at least the code will now run. When I save this, go into the app and now get a post. Of course, we still have an error here because VS Code decides to stop even on exceptions which are caught. But if we continue and go back to the emulator, we can see that we couldn't find the post message displayed. So this attempt called the exception properly, it got converted to a failure, and then we displayed it through this fold function to the UI inside the styled text. So that's awesome. And also what's going to work if we go back to post service and we do not throw an exception, we just return success data here, save that, run the program again. So get post, we can even see the successful data displayed. So why do we even need to change something when everything works just fine? Well, the issue lies in what I briefly outlined a while ago, and that is that the attempt function on the task catches every single exception. And what we are currently doing inside the post ChangeNotifier is that we just cast every single exception which is caught to a failure. And failures are simply exceptions which we expect to happen. But let's simulate that there is some sort of an exception from the post service which we completely do not anticipate. For example, let's just throw a file system exception from here, just for the sake of an example. This simulates a completely unexpected exception upon which the whole app should crash, because this is completely a fatal error and we do not want to have any risk. So we just want the app to crash whenever something like this happens. All right, so let's try that. We're going to run the getPost method again. And we have a file system exception, which is good. And then over here inside the post ChangeNotifier, which is where that exception is caught, actually, we get a cast error. So this is what you would see, for example, in a service like Firebase Crashlytics or something else if you are using some sort of a exception reporting service. This is what you would see. You would see a cast error, and while you can sort of understand what's going on behind the scenes because you can see the type which was not possible to cast to a failure, still, wouldn't it be better to simply rethrow this file system exception and not even cast it to a failure? Because this cast error really doesn't tell you much. And also you're probably going to lose any helpful stack traces which you can use to debug this error when you use something like Firebase Crashlytics. So what we want to do is, instead of just simply casting every single object which comes in here, which can be of a different type than a failure, we want to wrap this return statement itself inside a try-catch block. So inside try, we're gonna try to convert it to a failure, to cast it, and inside catch, we're going to catch an error here, and we're going to simply rethrow the exception. Of course, we cannot just use rethrow, because it doesn't make sense, since rethrowing it would still just rethrow the cast error and not the error in which we are interested. We want to instead throw the object, which, when you think about it, is just another exception, because we are inside the left side of either, which always holds an exception in there. The success data is always on the right side, so whatever comes into this left map function is always some sort of an error, some sort of an exception, something bad which we need to eradicate. So with this, when I now save that and open up the app again and get post, of course, VS Code will notify us all along the way, but let's not focus on that. What is important is this. Inside getOnePost, where we previously got the cast error, we now get the file system exception itself, which is definitely a much nicer thing to see on your Crashlytics than just some sort of a cast error. Okay, so we are basically done, but there is still one more thing we can do. It's not going to add any functionality, instead it's just going to beautify our code a bit. At the time of recording this tutorial in December 2019, Flutter Interact just happened a few days ago, and over there Flutter 1.12 was just released, and together with it, it supports Dart 2.7. That means support for extension methods. So we are going to hide this kind of long implementation of map inside an extension method to keep our code short. And I have a separate tutorial about extension methods, so I will not explain them in here in detail. So definitely check out that tutorial from the card in the corner if you want to learn more about extensions. Basically, what we want to do is to create an extension called task X for extension, which will have a type parameter extending an either, holding an object, and u, and also type parameter u, and it will be an extension on a type task holding t. So what this means, if you look at this, it's a task which holds t, which in this case needs to hold either an object or a u, and u can be just about anything, for example, a post. And also we need to update the constraints for an SDK to be Dart 2.6 at least, or maybe 2.7, I guess. Yeah, so let's just save pubspec.yaml 2.6.0 and less than 3.0.0 of Dart version. We can now implement this extension. Its return type will be a task, either, holding a failure, not an object, but failure now. That's important. And u, which can be just about anything, for example, the post, it will be called map left to failure, not taking any arguments. And from here, we just want to return this, which is that task on which we are writing this extension. So this is a task dot map, and we can actually completely cut this map call over here, not change anything, and it's fully implemented. And now we can just call from above. After attempt, we're going to call map left to failure, which calls our extension right over here. And with that, when I now save this and when I run it in the emulator, so we get a post, we get file system exception, of course. So that's something which is unexpected. So it's all right that the app does not entirely work with this file system exception. What we want to do, of course, is to not throw file system exception, but for example, throw something which we expect to happen. For example, this socket exception is good. So when we now run the app, we of course get notified about this failure, but that's cool because also after this notification from VS Code, we also get this error message displayed in the UI for the user to see. So that's awesome. And also when we now uncomment or actually comment out this socket exception and we return successful data, it will get converted to post just fine. Awesome. So I know there was probably a lot to digest in this tutorial, so make sure to go through it at your own pace once again, and also to get all of the code written in here from the written tutorial, which is available from the link in the video description on resocoder.com. So in this two-part tutorial, you learned how to handle errors properly in your Flutter apps, and especially in this second part, it may seem that there's a lot of new and weird code to write and to understand, but once you get used to this paradigm of programming, of functional programming, you are now going to be able to come back from it. And also, most of the code is really just a one-time setup. If you take a look at this post ChangeNotifier, for example, once you write this extension function, you are just going to use it throughout your app in multiple places, in multiple ChangeNotifiers, just like this, and you are not even going to think about its implementation. Lengthwise, it's really on par with just catching the exceptions in a regular way, but you get awesome tooling in the form of compile time errors whenever you do not handle a failure in your UI, and overall it makes your code just much more robust. So, if you are serious about this kind of programming and you want to become a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, and link is also in the description, to get the top curated Flutter news and resources aimed at improving your app development career. So over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And also, if you don't want to miss more tutorials like this, and also more tutorials geared toward the beginner type of programmer and not something like this elaborate coding with functional programming, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder I am absolutely determined to provide you with the best tutorials and resources so that you will become a sought after Flutter developer. If this video helped you with understanding a bit of a functional programming and also how to handle errors efficiently and robustly, give this video a like and also share it with other developers who will surely benefit from it too. Leave a comment if you have anything to say, and see you in the next video.